Alright, just going through some more Pythagoras sort of things. To figure out this one, you need to figure out this triangle here. And to figure out that triangle, how tall it is, it's going to be your 38, which is from there to there. Take away your 20 from there to there, and then it gives you this part here in the middle. 38 take 20 will be 18. So this triangle is going to be 18 high, and as we can see, 15 across. 18 high, 15 across. There is my answer. This one here, again, we need to just draw a line to get a right angled triangle, and it's going to be your 75 take your 50. 75 is from there to there, 50 is from here all the way down, which means you're going to be left with that part at the top. 75 take 50 is going to be 25. So your triangle is going to be 25. Hypotenuse is 40. This is what you don't know. It's going to be 25 squared plus x squared equals 40 squared. I think that's 625, isn't it? 25 times 25. 625 plus x squared equals 40 times 40 will be 1600. Then you're going to take 625 from both sides, and that will end up getting you 575. No, 975, sorry. Silly me. You get 975 on one side, you get x squared on the other. Then you have to square root both sides. And then you're going to get x equals square root 975. Which is 31.224. 31.22. There's that one. Alright, onwards we go. Trigonometric ratios. So it's just getting you to practice what the sine is, the cos and the tan for SOHCAHTOA. Super important that you remember this. So for A, you've sine opposite over hypotenuse is 5 over 13. For B, it's going to be 10 over 26. That will simplify to 5 over 13. Sign in the middle. The next one is going to be 15 over 39, which if I divide both of those by 3, I'm going to get 5 over, I've put that in the wrong spot, 15 over 39. That's going to be 5 over 13 as well. Now, adjacent over hypotenuse. Adjacent over hypotenuse for A is going to be, wrong one, sorry. Adjacent is this one. That's hypotenuse. That's going to be 12 over 13. If I do it for C, so it's going to be adjacent over hypotenuse. It's going to be 36 over 39, which is also 12 over 13. These are really the same triangles. They're just they're in the same proportions, so the answer should all be the same. And for O over A, we should be getting a 5 over 12. There's our 5, there's our 12. And the other one is going to be 10 over 24, which will simplify to 5 over 12. You should be able to see 13, 26, 39, 5, 10, 15, 12, 24, 36. They're just going up in equal proportions. All right, onwards we go. Definitely remember this. This is ultra important, and that I'd recommend you write this down. That way you get to know these things and draw that beautiful little triangle. Okay, so I'm just going to use words here when it comes to the words part. But I'll just say it out loud. What is the length of the hypotenuse? It's the long side, so it's 13 meters. What is the length of the side opposite theta? There's theta. There's opposite, so it's 5 meters. And adjacent is always the one just next door. And that one is 12 meters. So H stands for hypotenuse, O stands for opposite, A stands for adjacent. Sine theta is going to be opposite divided by hypotenuse. Cos theta is going to be adjacent divided by hypotenuse. And tan theta is going to be opposite over adjacent. Okay. And now just labeling the sides. Hypotenuse is always opposite the right angle. And opposite is opposite the theta. Theta, there's my theta, there's my theta, there's my theta, and that, there's my theta, and then adjacent's the other one. Adjacent's always in between the two angles if they've got the two. Well, for these examples, it's not always going to be like that. It might not always be so simple. They might not always give you the right angle. They might expect you to just be able to see it. All right. Now to solve these, a trigonometric ratio. So here, because I've got the hypotenuse, right, and I've got the opposite, what I might do, I might write my SOHCAHTOA over here, so we don't forget. Okay, we've got the hypotenuse, we've got the opposite, so we need to use O and H. That's going to be sine. Sine is going to be, and it just wants in fraction form. I don't remember if this one wants the numbers, but we can just put the numbers in. Sine theta is going to be opposite over hypotenuse. It's going to be 4 over 7. This one is going to be opposite and adjacent. That's going to be tan. Tan equals opposite 5 over 4. This one is going to be hypotenuse and adjacent. So A and H, that's going to be cos equals adjacent 6 over 10, which equals 3 over 5. This one is going to be your opposite and your hypotenuse. So that's going to be sine. So that's going to be 4 over 6. Sine equals 4 over 6. That obviously is 2/3 when you simplify. This is 5 over 5, which is just going to be 1. So, and this one, it does have the adjacent and it has the opposite. So adjacent and opposite is TOA. It's going to be tan theta equals 5 over 5, which is just 1. This one, you've got there's opposite, there's hypotenuse. So you've got adjacent and hypotenuse. This is cos equals adjacent over hypotenuse. This one will get you, so no hypotenuse again. So no hypotenuse means you've got opposite and adjacent. So tan equals opposite over adjacent. 3 and 6, that's the hypotenuse, and got the adjacent, so that's cos equals 3 over 6, which is a half. And this one, again, you've got no hypotenuse, which means you've got opposite and adjacent. So 5 tan theta equals 5 over 3. For each of these triangles, write a ratio in simplified fraction form, sine, cosine, and tan. So, for all of them. Okay, so for this one, it would be sine theta equals, and for sine, again, I'll just write it down for everyone, SOHCAHTOA. So opposite over hypotenuse. Opposite over hypotenuse. Sine theta will be 3 over 5. For cosine, adjacent over hypotenuse, it's going to be 4 over 5. For tan theta, it's going to be opposite over adjacent, 3 over 4. For B, this one, the sine one, will be opposite angle over hypotenuse. Sine is 24 on 26. Cosine will be adjacent over hypotenuse, 10 over 26. And the last one, tan, will be opposite over adjacent, 24 on 10. And the last one, sine, cosine, opposite over hypotenuse will be, your opposite is 12 over 13. The other one's going to be 5 over 13. And the other one's going to be opposite 12 over 5. Hopefully that's easy enough. Okay, here are two similar triangles. Write the ratio sine theta as a fraction for triangle A. So they're going to be actually the same because you should be able to see that the numbers just double. But it's wants it for triangle A. So the sine theta option, which will be opposite over hypotenuse, opposite is 5. It's going to be 5 over 13. Is the fraction, and for the other one, it's going to be 10 over 26, which can simplify to 5 over 13. What do you notice? They're the same. Right, the ratio of cos for both of them. So cos, again, is adjacent over hypotenuse. Adjacent over hypotenuse, that's 12 over 13. Other one is going to be 24 over 26, which can simplify to 12 over 13. So they're the same. And then after that, the ratio tan for both of them. Tan is opposite over adjacent. So 5 over 12. Oops. 5 over 12. And for B, it's going to be 10 over 24, which is 5 over 12. And they are the same. Okay. This Roman temple, we need SOHCAHTOA. I'll write it a bit more in full. Sine theta is going to be opposite over hypotenuse, 3 over 5. Cosine theta is going to be adjacent over hypotenuse, adjacent over hypotenuse, 4 over 5. And last one, tan theta, is going to be opposite over adjacent. Opposite over adjacent. Okay, number 8. Vertical flagpole casts a shadow 20 meters long. If the pole is 15 high, find the ratio for tan theta. Tan is going to be opposite over adjacent. So my opposite is 15, which is going to be tan theta equals 15 on 20, which you can simplify that to 3 over 4 if you divide both of those by 5. You should know any numbers that end in 5 and 0 will be divisible by 5. The triangle shown, state the length of the side that corresponds to the hypotenuse. The hypotenuse is 5, opposite the right angle. The side angle theta, or the side opposite angle theta, is going to be 4. The side opposite angle alpha, I guess, 3. That's my adjacent side. The side adjacent to angle theta. If this is theta and that's opposite, the 4, the adjacent one to theta will be 3. And the side adjacent to this one, the opposite will be 3, but adjacent to it will be 4. You've got to be careful where the angle is. That changes what is opposite and what is adjacent. For the triangle shown on the right, write a ratio in fraction form for sine theta. So sine theta, if here's my theta, sine be opposite over hypotenuse. So it's going to be opposite 8 over 10. 8 over 10, which simplifies to 4 over 5. For D, tan alpha. Tan is opposite over adjacent. Opposite of alpha is 6. The adjacent is 8. So that's going to be 6 over 8, which equals 3 over 4. For sine alpha, opposite over hypotenuse. The opposite is 6, so it's going to be 6 on 10, which is, of course, 3/5. Cos alpha. Cos is adjacent over hypotenuse. Adjacent is 8. Hypotenuse is 10. That's going to be 8 on 10, which is 4/5. Cos theta is going to be adjacent on hypotenuse. Adjacent to theta is 6. Hypotenuse is 10. 6 on 10, which equals 3/5. And tan theta, opposite over adjacent, is going to be opposite 8 over adjacent 6. 8 on 6 equals 4/3. Okay, draw a right angled triangle, mark one of the angles as theta. So if I do a right angled triangle, this, and I'm going to make that one my theta. So there's one little theta. Marking the length of the opposite side is 15, and the length of the hypotenuse is 17. Use Pythagoras to find the length of the adjacent side. So that'll be 15 squared plus x squared equals 17 squared. I think I know this one off by heart. I think it's 225 plus x squared equals 289. And the thing that's missing is 64. And therefore you square root that. You get square root 64 equals 8. So they cancel out. Alright, find the length of the adjacent side. So we just did that. It's 8. That side is 8. And determine the ratios for sine theta, cos theta, and tan theta. So I'm just going to get my eraser and rub out a lot. Can I rub out a lot? Oh. Now I've got room to do my writing. Okay, so sine theta. So there's my theta. Sine will be opposite over hypotenuse, so 15/17 is my sine. My cosine is going to be adjacent over hypotenuse. There's adjacent, this hypotenuse, so it's going to be 8/17. And my tan is going to be opposite over adjacent. It's going to be 15/8. Okay, last question, I believe, number 12. It's those ones there. This triangle has angles 90, 60, and 30, side lengths of 1, 2, and √3. Write a ratio for sine 30. So the sine of angle 30, so SOHCAHTOA, is going to be opposite over hypotenuse. Opposite is 1/2. Okay, cosine 30 is going to be adjacent over hypotenuse, so it's √3/2. Next one is going to be tan 30. That is going to be opposite over adjacent, so that is going to be 1/√3. 1/√3. Then we've got sine 60. Sine 60, so it's going to be the opposite over hypotenuse. Opposite √3/2. Then you're going to have cosine 60, which is adjacent over hypotenuse. Adjacent is 1/2. And lastly, tan 60 is going to be opposite over adjacent, √3/1, which of course is just √3. Okay, what do you notice about cosine 30 and sine 60? Cosine 30, sine 60, they're the same. So this one, same. And then what about sine 30 and cosine 60? Sine 30 is a half, cosine 60 is a half. They're also the same. So yeah, that's pretty much all we're going to do for now. Leave any questions in the comments.